Today we're going to be talking about dividing decimals, and you might be asking yourself, why do I need to know how to divide decimals? Well, because if you ever expect to work with money, you might need to know how to do that. Also, you're not always going to have a whole number that you can divide by, so decimals are going to come into play many more times in your mathematical world and in your math classes that you're going to be taking later on. So let's get started. We talked about the why, money and non-whole numbers. Those are just a couple of examples. But let's talk about the how. Remember when I taught the lesson on how to multiply decimals? We estimated with our products, and then we placed the decimal afterwards to see where it made sense. Today we're going to do the same thing with dividing decimals. So I want you to take a look at our first problem here. We actually have 40 and 5/10 divided by 3, but I want you to think in your head right now, 40 divided by 3. Well, I know that 3 times 10 is 30, so that's close, right? So most likely my answer is going to be a 2-digit number. And when I look at this answer up here, this is the correct answer. It just doesn't have the decimal point in there yet. So if we think about where would the decimal make most sense, it would make sense for it to be right here. Okay? So if I actually divided this problem out using the traditional method and kept my place values in the correct spot, my numbers in the right order, I'm going to show you a little bit later where we would put the decimal point in that situation. But with estimating, this is what we would do. So we would think 40 divided by 3 because this it's a lot easier to say 40 divided by 3 instead of 41, even though that's a 5, because most of you probably couldn't do 41 in your head. And I didn't round the 3 just to make it a little more simple, because we're not going to say it's divided by 0, because that's not a 5. So we're going to go ahead and do 40 divided by 3 in our head and think, oh yeah, that's about 10. So when we look at the answer, we can guess where that decimal point is going to go, because it would not make sense for me to say that the decimal point went here. 135 would be way too big. So anyway, that's our first example. If we take a look at our next example, we have 150 and 88 hundredths divided by 4. Now the division has already been done, and I've got 3772, but I'm not sure where that decimal point goes. So I'm going to think a couple of different ways. You can think 150 divided by 4, which might be a little bit harder than if I thought 200 divided by 4, because we could round 150 and 88 hundredths to 200 and make that divided by 4. And the reason I stayed with 4, because it's less than 5. So anyway, so when I look at this number, 200 divided by 4, I can do that in my head. That's about 50, right? So when I look at my answer here, would it make sense that my decimal point was way over here to say that my answer is 3,772? I don't think so. Would it make sense that my answer was 377 and 2/10? I think that one's too big as well. So it would make sense that my decimal point would go right here, 37 and 72 hundredths. Okay, let's try another one. We've got 2 and 52 hundredths divided by 6. And again, I'm going to think 3, I'm rounding this decimal to 3, divided by 10. Oh, that sounds a little wrong to me, doesn't it to you? 3 divided by 10? That means that my answer most likely is going to be smaller than 1. It's not even a whole number, because what can I take 3 divided by 10? I can't take anything times 10 to get 3, can I? So this is going to be a non-whole number, or not even a whole number, so it would make sense, looking at this, that my answer is going to be 42 hundredths or 42 10,000ths. okay, when you see those zeros on there. So this is how we would do this method if we were estimating, okay? We're going to do one more with estimation, and then for those of you that are comfortable with dividing with the traditional method, I'm going to show you how we would do it using that method. So, again, I have 1 54/100ths divided by 7, and the real answer is somewhere around these digits, right? It's going to be 2,200, 22, or 220. So again, I'm going to take this 1 54/100ths, I'm going to round it to 2, divided by, and this time I rounded that 7 because it was larger than 5, and in my head it's easier to divide by 10. So 2 divided by 10, again, this seems a little odd, doesn't it? Because 2 in here and 10 out here, that would mean that I'm taking 10 times something to equal 2. That doesn't fly. So that means that my number or my answer is going to be smaller than 1. So it would make sense that my decimal point would most likely be here, which would make that answer 22/100ths, or if we have the zeros on there, we'd have 22/10,000ths. Most of the time we don't carry it over that far, but just so you know, that would be the correct answer. So if you punched that into a calculator, of course it's going to place the decimal point for you, but you would see those zeros. So let's take a look at the traditional method. I put a problem up here, 153 88/100ths divided by 4. Now what I want you to think about is if we're using the traditional method, then I would have places, so you need to imagine that when I divide, this would be my place value spots, okay? And so eventually I'm going to make my way over. I've got a decimal point right here, so I'm going to think to myself, does 4 go into 1? No. And if you want, you can put a 0 here so that you know that you tried that spot. And then you're going to think, does 4 go into 15? Well, yes, it does. 4 times 4 is too big, so it's going to be 4 times 3. So I'm going to place a 3 right here. 3 times 4 is 12. Then we're going to subtract. I cannot take 4 into 3, so I'm going to bring down this 3. 4 goes into 33 7 times, or actually 8. 4 times 8 is 32. Then we're going to subtract. I cannot take 4 into 1, so I'm going to bring down that 8. 4 goes into 18. 4 times 4 is 16. 4 times 5 is too big, so we put a 4 here. Multiply, subtract. 4 does not go into 2, but we bring down that 8. And 4 times what equals 28? 4 times 7. And we subtract, and we don't have anything left. Now, here's the magic. We have a decimal point right here, right? All I'm going to do is move that decimal point right here. So that means that my answer is 38 47/100ths. Now this only works if you really understand how to use the traditional method, and you can make sure that you keep all of your digits in the correct place and make sure that your place value is all lined up. Notice I've got this number above here and here and here, nothing up there because the 4 wouldn't go into 1, and that's how we decide where that decimal point would go. Now, if we estimated with this problem, I would have thought 153 88/100ths would round to 200, just similar to the other problem that we did a few minutes ago, and I would think in my head 200 divided by 4, and we know that that's going to be 50, And when I think about my answer, I need a 2-digit number, not a 3-digit or a 4-digit, okay? So depending on whichever method that you are most comfortable with, by all means use that method, and especially make sure you get the right answer before you decide to try this method, okay? I do have some students though that are pretty good at the traditional method already, so if you feel comfortable using this, you can. If you want to start with the estimation method and then work your way up to that traditional method, that's fine too. Alrighty, I'll see you next time. Bye!